So today our topic is software testing, and let's try to understand some of the basic ideas of software testing. So before even we go any further, let's try to understand what is software testing, generally speaking. So anyone who would like to add something here, what is software testing? Any answer? Anyone who would like to say something? What is software testing?
Test the software and see if there is any bug or a problem.
Okay, yeah, software trying to test if there is any bug or problem in the software, right? So we have few things to keep in mind. One of the thing is in the context, we have to understand that we already discussed this keyword verification and validation. Remember this? And we said that we do verification and validation at different phases of the software development, right? We do the verification validation in requirements. We do verification validation in design. Similarly, we also do verification validation for implementation. So if I verify and validate and the artifact is my implementation, like my source code, right? The code. Then software testing is a verification and validation technique. Sorry, what's going on? Software testing is a verification validation. Software testing is a verification validation technique that applies to implementation. Okay. So basically, understanding that way, we are saying what is software testing is one of the technique of verification and validation, and it applies to implementation. We don't do software testing for requirements. We don't do software testing for design. Once we implement, we do software testing for our implementation. Okay. This also explains one more thing is there are other techniques of verification and validation for implementation. Anyone who can think about any other technique to verify or validate my implementation?
Maybe release some version for my application, like beta and something like that.
Yeah, and but that would also be this beta release will also be some sort of testing, right? We have concepts that keywords like alpha testing, beta testing, and stuff like that. But for example, there's other techniques like code review, right? Code review means people either independent from the project or people from within the project formally goes through the code to look for issues. So that's also another technique for software verification validation of the code. Of course, the most important thing is the software testing, right? Now, what do we do in software testing basically? In software testing, the thing which we do is that we execute the code. That's very important, right? So we execute, or what we call the run the code, right? Run the code. So it's a dynamic form of verification validation, right? Not a static form. It needs execution of the code. So there's another thing is what do we do in testing in a very basic form is we provide input. Okay. Right. And compare what? And compare the output received or achieved or actual output, we call it actual output with expected output. That's the important part of testing. This is one important aspect, right? So here, what we are saying is we have input, we have actual output, we have expected output. So that's one important aspect of software testing is you run the code, you provide input, then you check the output of the system and you compare it with the expected output. Of course, this type of testing is mainly for testing the functionality of the system, right? This is system functionality testing, which is one important part of software testing. The other types of testing is the idea of testing. So let me put it here. So we do functionality testing. Okay. Functionality testing. And the other thing is testing software quality, which is a bit different, right? So you want to test the reliability of the system or efficiency of the system. So for example, it says the system should support 1000 concurrent users. If you want to test that, basically you run the software and you make 1000 concurrent requests to the server, for example, and check how does the software behave. So that's some sort of quality testing, right? But one of the most important part, which takes also a lot of time, is the idea of functionality testing, where the core idea is to provide input, check at the actual output, and compare it with the expected output. Good. So yeah, if you have questions, you can let me know. As otherwise, I keep going forward, right? So this is the very basic idea of testing, and which also introduces us to one more topic, that software testing. There are different goals of testing. One of the goal of the testing is that we need to find defects in the code. So defect testing, looking for problems, looking where the software might behave incorrectly, right? And one of the idea here is to check the actual output with the expected output. If my actual output and expected output does not match, that's what we try to look for in defect testing. But then there's also other reasons or goals of testing, like conformance testing. We want to show that yeah, the system is working okay in terms of quality attributes, in terms of functionality and stuff like that, right? So basically, testing also has addresses both the goals of software, both verification and validation. And of course, we understand that software testing is very important because a lot of software troubles can come if you don't do the testing. So if you don't do proper testing, what are the consequences? Think about it. If you have not done enough testing, what are the consequences of this? Let me know. What do you think about it? What are some of the consequences of not testing enough? Anyone? The product will fail. Of course, if you don't do enough testing, you might have situations where there are bugs or errors, and that might lead to system failure, right? Crashes or whatever. Now, how costly are these? These are depends on, of course, the software, the nature of problem, and stuff like that. But we can understand that if you don't do enough testing, it can lead to major issues. It can lead to huge financial losses. It can lead to loss of lives, of course, if the system is critical system, or if, in general, it will lead to poor user satisfaction. Even if the software is not very critical or safety critical or financially business critical, still, if you have a lot of bugs, the users are not going to be satisfied. The user satisfaction is going to be affected by that. So we have to be careful that we do enough testing. And as we saw before, that in many of the projects, testing takes a big portion of our whole project life cycle. So it can take even 30–40% of the whole time of the project, ideally, that we should spend in software testing. So yeah, it's very important, it's very crucial, right? But then we have to understand one thing. For example, right? Uh, let this be clear. What we are saying here is, if you are doing defect testing, right, then software testing can show defects, right? Software testing can help you show the defect, right, or presence of error. But this is very important. Software testing does not show absence of error, absence of defects. What does this mean? That if you do testing, hopefully you're going to find issues where your software is failing. There are faults, right? So you show this and you fix that. But doing testing, and you did some testing, let's say you did hours of testing or months or days of testing, doesn't mean that if you did not find fault, you can guarantee that there is no fault. Is this making sense? So it can show defects to be fixed, but if it does not show defect, does not mean that your software is bug free. This is very important concept, right? It's very difficult actually to guarantee bug free code. But of course, the idea here is the more you test, the more you test, the more you have confidence that software is free of bug. Is this making sense? This is a very important concept, right? So the more you test, the more you can have confidence that your software is free of bug. But you don't normally, in a very normal circumstance, unless you're doing very special type of testing, not even testing, software development. The whole development is concepts like formal methods where you have proofs. So unless you're doing that very special thing, normally testing does not guarantee absence of bugs. It can only show you presence of bugs if there are bugs. And the more you testing you do, the more confidence you have that your software is having less bugs, right? But not no guarantees. This also introduces another issue. Let's say I have hundreds and thousands of functionality or whatever number of functionality. What do you think would be a good strategy? If you have limited time, should you test the most common functionalities or the least common functionalities? What do you think? What should be the idea? Any answer? Most common, exactly, you're right. So we should be looking for most common problems because again, as we say, we don't guarantee defect free code, but naturally the code which is used more often or the most common or most useful functionalities, that should be at least bug free. So we should first spend our most effort, we should focus, give high priority for those functionalities which are used more frequently, which are most useful functionality in my code, right? So that should be done first. But of course, doesn't mean that those which are not used much, we should not do any testing to it. But if there is a place where we need to make some resource allocation and time allocations, we should have special concern or consideration for those piece of software which is used a lot or which is very important or useful. That's tested more. That's the idea here. Okay. Now there's another thing is the term the term testing versus debugging. These are two different terms, right? So who can tell me the difference between the term testing and debugging? Any idea? How is testing different than debugging? Basically what happens is if you do testing, as we said, testing can show defects, and these defects are basically called as bugs, right? So basically the job of testing is to show bugs, but not fixing of the bug. That's not part of testing, technically speaking. So you show bugs and you give it to the author of the code, the implementer. He looks at these defects, these bugs, and tries to fix them. That's the idea of debugging. So testing is basically showing bugs. Debugging is basically fixing bugs. Is this idea getting clear? So this is important concept again. Now, again, another important thing is we say that the more we do testing, the more we have confidence that the software is bug free or has little bugs, fewer bugs. But it cannot guarantee that there's no bugs. Now, think about this. Is this possible as a scenario that I launch a product and I already know there are bugs? Does this happen or no? Think about it and let me know. That do people launch products as companies or organizations or individuals knowing that there might be bugs? And the answer is yes. So what happens in some products, you might know that there are some bugs here and there, and at the same time, you might go for software release. Again, why we would do that if we already know that there is bug? There are many reasons for that. One of the reasons is sometimes what happens is you have very strict release schedules. You cannot delay your release schedule. So although you know that there are a list of bugs, you try to fix as many as possible before the release, and hopefully the ones which are more important and the lesser important ones you leave it and you fix it later on. So you have software fixes, right? The updates, software updates, where you fix those bugs. So this is one thing. So because of tough or very strict release schedules. Also, the nature of the software, sometimes these bugs are difficult to fix, and maybe those bugs are not very harmful in the sense that it does not have a very big effect in the software or the user experience. So knowing, yeah, there is some issue, you might still let it go. But of course, that doesn't mean that any bug can be let gone, right? So, for example, you're looking at some critical system and you know there's a bug. No, you can't release that. In fact, to the point, ideally you should not release it, even if it makes a delay and it makes loss of financial losses, other thing. You want to stop, you want to make sure that you fix those bugs. If those bugs are very critical bugs, right? But at the same time, we know that normal softwares which are not that safety critical or very highly financial critical, people let the software release even though it has some bugs for some other reasons, many reasons, right? So as I said, it could be some tight release schedules. It could be that it's bug, but it's difficult to fix and takes a lot of time, and it's not really worth it right now because this functionality is seldom used by anyone, and you can maybe release it and later fix it. So it happens in reality. Okay. Now, yeah, so there are other concepts which are important in testing. So one of the concept here is faults versus failure. Okay, what's a fault and what is a failure? Okay, so what happens is faults are the problems in the code itself, right? So for example, I say write a method that finds let's say square root of a number. So you have a method, let's say square, let's say not square root, let's say square. I take an integer assuming, right? And what I have to do is I have to return the square of the number. So I said, for example, again, just for clear understanding. So I just say return num star 2, right? So if I have to return the square of the number, I should have returned ideally num times num. That's the square, right? Num square. But by mistake, somebody wrote num square times 2 instead of num times num. So this this problem in the code, this is called a fault. Okay. What is failure? Failure is once you do testing, what we said, we check the input with the expected output, right? So for example, what happens if I say input, and this will say expected output, and we'll say actual output. What if I have two input as 2? What's my expected output? My expected output is 2 square, which is 4. And if I run this code, what happens? My actual output is also 4. So there is a fault in the code, but there is no failure. The system is not having a failure because it's performing as intended. So you see here, this is the trick here. So sometimes if you don't design your test cases comprehensively or intelligently, then you might see that you don't find any failure, although there are faults in the code. But for example, if you say 3, what's your expected output is basically 9. But what do you get actually? You get 6. So here, this is what is a failure. So what do you do is once you do testing, you identify the failures. You look at the failures. And these failures are used to debug and find the faults. So failure leads to fault. Can one failure lead to multiple faults? The answer is yes, of course, right? So for example, I can have another fault. Yeah, can one fault leads to multiple failures? So example is very obvious, right? So this expected output is 16, what you're getting is 8. So these two failures are basically based on the same fault. So one fault can lead to multiple failures. Similarly, right, there can be multiple places you have fault, and those failures are evident. Those faults are evident from one single failure. So this failure might map to this fault, but it could be for other faults also. So you have to be careful, right? So once you fix your code, you have to make sure that you're fixing it not in one place. It is to be fixed in all these different places which is applicable. So fault and failure is important concept. Testing and debugging is important concept, and the idea of testing that you give input, you compare your expected output with your actual output. These are again very important concepts to keep in mind, right? So keeping this in mind, let's go forward. Then we have these concepts. So there are other concepts like, so important terms. There is something called black box testing versus white box testing. So what's the difference here? In black box testing, what you do is you design test cases looking at the functionality. So basically what you're doing is you're treating your system as a black box. So your system for you is a black box. You can't see inside. You can't see inside. So this is your system, right? It's a black box. So you know, if I give this input, this is my expected output, right? But you cannot look at the system inside. Means in a sense, you don't have access to the code. This is the idea of black box testing, right? So black box testing is also very important for functionality testing. So if I give input, I know what output to expect. And also here, which is very important, is that the idea of testing, one of the core idea we spoke before, is the idea of test case generation. Test case generation is the activity in testing which takes a lot of time. This takes most of the time. And what is test generation? Is the idea that what input should we try? So we have, for example, test case 1. This input should we try. This is the expected output. So to come up with this, so there might be multiple inputs, right? Input 1, input 2, input 3. So all the inputs and what is the expected output. So coming up this thing, the inputs and expected output, this is the test case generation, what to test with. And what for every test case, what is the expected output. This is what takes a lot of time. Now in black box testing, you are not designing your test cases looking at the code itself. You're just looking at the system functionality and deciding your input and expected output. So the question is, what do you think would be a good artifact to create test cases for black box testing? Let me know. How are we then going to create test cases for the black box testing? If I don't see the code, what is my input as an artifact to do test case generation for black box testing? The idea here is that the most important artifact for my black box testing is requirements. Let's say system requirements. Because system requirements is telling you, I enter this, the system responds like this. I enter this, the system responds like that. So based on the system response and the user input, I decide exactly what input to give and what to expect, right? So that's a good thing also in a sense that we said testing is a time consuming activity, and one of the most challenging and time consuming activity is test case generation. The good thing in black box testing is because the input is system requirements to create test cases, you can start creating test cases right after requirements is ready. You don't have to wait till implementation, right? So this is a very important concept. On the other hand, what is white box testing? White box testing is where you treat the system as a white box. In a sense, you can look at the code. So you decide your test, the input output pair, based on the looking at the code itself. That's white box testing. Okay. And again, if you have question, let me know. Stop me and if you have any question. So white box testing, you're looking at the code to decide what to test with, what inputs to test with. And there you look at if else, for loops, stuff like that. Then, okay, what might go wrong? Let me try these ideas. Okay. So this is the idea of white box testing. Of course, white box testing, you cannot create test cases until your code is ready naturally, because you have to look at the code to decide your test cases. But black box testing, as we said, you can create the test cases even quite earlier, even before design to some extent, right? So this is important, and this also explains us there's a V model for software testing. What's the V model for software testing? To understand that, let's understand some more terms, some more keywords. So there are concepts in software testing is called, for example, unit testing. You have integration testing, and you have system testing. Okay, so these are again important concepts for us to understand. What is unit testing? What is integration testing? And what is system testing? Good. So one of the important thing here is that unit testing is testing a unit, right? For example, it could be my unit could be a class if I'm speaking of object-oriented system. Okay. What is integration testing? Is testing collection of classes as components. So you integrate thing into system components and subsystems. So that's integration testing. And system testing is testing the whole system. Testing the complete system. Okay. Now, who does the unit testing? Who does the class? Test the class. Normally, it's the same person who develops that class. So if I am implementing a class, I do the unit testing. So think about this. Generally speaking, what do you think? Unit testing should be black box testing or white box testing? Let me know. What do you think? What makes more sense? Unit testing to be white box testing or black box testing? Actually, it's done by the same person yeah, exactly. So the answer is right. It's white box testing, right? Why? Because you are writing your code. Once you implement it, you test it. So that's unit testing, right? So it's white box testing. Similarly, integration testing, what you're doing is you want to test the if individual classes are working okay in by itself. Now you want to integrate them to work as a component or a subsystem. So you want to know how is it working by integrating them. Alone it's working, but if you integrate them, is it still working, or there might be defects because of the interface between them, right? So that's integration testing. And the idea of integration testing is, let's assume that you have to integrate, let's add a new page here. So in integration testing, let's assume you want to test this component in a sense or subsystem which has these classes. For simplicity, let's assume only this is the structure. So you have class 1, class 2, class 3, and class 4, assuming, okay? This is your component or a subsystem. Now you have integration testing is done after unit testing. So you know that by itself C1 is working because you have done unit testing, C4 is working, C2 is working, C3 is, everyone is working. Now if you integrate it, you know there might be problems, right? But if the problem is occurring, so you find a defect, a fault, basically a failure, then this is most likely because of the integration of the classes, because each class you are expecting it to work okay. So what we do is, in integration testing, what we do is, the idea here is integrate incrementally and test. So what it's saying is, instead of integrating all of them together and then testing it, what you should do is integrate incrementally. For example, I first integrated C1 with C4. I do the test. So I know C1 is working, C4 is working. Now I integrate it. And if both of them is working, then I integrate another one and test the three together. And if these three all are working, I integrate the last one and so forth. Why we do this type of thing? Why we do this incremental integration and testing? Because this helps you find the defects easier. Because if you integrate all of them together and you find failure, it's very difficult to know where is the fault. The fault is because of the integration of these two or integration of these two. Where is the fault? But if you do it incrementally, think about this. So if you do incrementally, you know C1 and C4 is working, but if you integrate them and you have a problem, you know the problem is only because of the integration of C1 and C4. If this is working, now you add another one, C2. If the problem is there, you know the problem is because of integration of C2, not because of C1 and C2 integration together, right? and so forth. So it becomes to localize the problem, it becomes easier. So it's a very important concept that you test incrementally. Again, think about it. Because you are incrementally integrating system and testing the integration of the system, is it making more sense to be white box testing or black box testing? Yeah, and the answer should be it's a white box testing, right? Because you are integrating it incrementally, you're looking at the code to integrate it and doing testing to find out what's the problem with integration. So it should be ideally a black box, I'm sorry, a white box testing. Now coming to system testing, right? So what we have in system testing, again, system testing itself can be few things. For example, one of the things you can do in system testing is functional testing, right? The other is non-functional testing, or most importantly, sometimes people use the word for performance testing, right? Or non-functional testing. Good. And then you have also something called acceptance testing. This is very important. So functional testing is basically, so what is system testing? System testing is after you have integrated everything. Now it's a system and you test it. So either you test for its functionality, is it okay? Or test for non-functional requirements like performance, basically, or other attributes. Or there's another concept called acceptance testing. And acceptance testing means, again, you test, and if the test cases passes, your acceptance test case passes, the customer accepts the software. In a sense, they take the software, right? You, in a sense, you are also committing to the, you delivered your contract. Okay. And normally in acceptance testing, what you do is this functional and performance, you might do it in your own software company environment. But acceptance testing is done in real, or let's call it customer environment. So the data and the environment, the setup is a real time. It's a real one. But here it's almost like a lab test. So you are doing it in your own software, locally in your company, for example. No, this one is real deployment and testing. So that's acceptance testing. And as I said, if this test cases passes acceptance test case, the customer accepts the software, right? So you fulfill your contractual obligation in that sense. Okay. So think about this. So system testing, you are everything has been integrated and you're testing the whole system as a system. So basically, the idea here is system testing should be black box testing. This is the concept here. So it should be a black box testing. You're looking at the system as a whole. Okay. And this is very important. Now this introduces us to something. Now you have, if you do software development and you're doing implementation, what are you doing? You first create a unit, you create classes, right? And from units, you come with the integration. You integrate the units and then you have the system ready, right? We said before, unit testing is normally white box testing, integration testing is white box testing, and system testing is black box testing. Now, what we said is that unit testing, right, is done the first thing. First, the units are tested, then integration is tested, then the system is tested. But on the other hand, if you want to do create your test cases, which takes a lot of time, which among them, unit test cases or integration test cases or system test cases are going to be ready first? What do you think? Which test cases can you get ready first? Actually, the answer is system test cases. Why? Because system test case is a black box testing, and the artifacts you use to create test cases are your requirements document, which is quite early available. Whereas unit testing and integration testing, you cannot create test cases until you have access to the code because they are white box testing. So what happens is the one which is to be tested later, right? Actually, some of the designs is later on, they can be used in this way. So integration testing, the test cases are created first. and then the integration test cases are created, and then the unit test cases. These no, of course, these test cases are created later on after your implementation is there. Test cases, right? So the testing, right? It is created first, but it's tested last. And this is tested last. Let's call it this system testing. Tested at the end, but test cases generated in generated earliest, let's call it. Is this clear? So another way to write this down is people use something like this. So you have system testing, you have integration testing, you have unit testing. You create test cases for system testing, test case generation, you have integration testing, test case generation, you have unit testing, test case generation, and then actually you do the actual unit test. Perform unit test. Then you perform integration test. And then you perform finally the system test. So this is some sort of rotated V. That this is test cases generated earlier, then next, and then you perform unit testing first, then integration testing, and then system testing. Of course, this is the input you get. So this is called the V model, right, of testing. So yeah, this is important as concepts. There's also one concept here, which is also important in the context of integration testing. So what happens is we said, and again, by the way, this concept is used other places also, but good to demonstrate in integration testing. So this idea is called regression testing. Regression testing. What is the idea here in regression testing is that once you have unit tested C1 and you have unit tested C4, you integrate and test. Okay, and you test some test cases. Now, once you have integrated another one, right, and you find some defects, let's say you find some defects after integration of C2. Now, after you find defects means basically you found the failures. Now, debugging will try to locate the faults and fix it. Now, once you fix those defects, you have to retest the whole test cases, not only those test cases which were failure. So doing the test again, complete test again and again, this is the idea of regression testing. Okay. So again, my point here is this, let's be clear, that if you do test cases, right, and if some test cases fail, you fix the fault and you retest the whole test cases, not only those which fail. Why you do that? Because we know if you do debugging and we fix some of the faults, it might lead to other places some faults, again, if you're not careful. So regression testing makes sure that you don't only test those fixing, you have to test the whole thing again and again. So whenever you fix something, you retest the whole thing again. That's the idea of regression testing.